So we got a 100-gram samples of two different compounds consisting of only carbon and oxygen. You've seen this before. So one of the compounds we have 27.2 grams of carbon, and another one we have 42.9 grams of carbon. We already know now, we've done this a few times, this is carbon monoxide and carbon dioxide. John Dalton, however, didn't know this at the time, but he did observed this phenomena, called it the law of multiple proportions. What's the second part here saying? How can these data support the law of multiple proportions if 42.9 is not a multiple of 27.2? Well, these are the 42.9 and 27.2 are the masses of carbon in these compounds, in these two compounds. Let's call it compound 1 and compound 2. And there could be compound 3 and compound 4 and so on. But there's a series of compounds, and each of those compounds, if they have two elements, right, and if one of them, the ratio of the second element to the other one are multiples of each other in whole numbers. That's what it says. So the answer to this question is not saying that these are multiples of each other when compared to the mass of the entire compound. The law of multiple proportions says they are multiples of each other when compared to 1 gram of the other element. And it may be easier just to show you how to work out this problem. All right, so if we have 42.2, sorry, if compound 1, let's say, has 42.9 grams of carbon, all right, then the amount of oxygen must be 100 minus that, because those are the only two elements in this compound. All right, 100 minus that is just 57.1 grams of oxygen. All right, now in compound 2, we're told that there's 27.2 grams of carbon. So 100 minus that is going to give you 72.8. Yeah, that's right, grams of oxygen. So to get this in a ratio where it's per 1 gram, so we want to get this, all of this stuff, in terms of per 1 gram of one of the elements. So in this case, oxygen. We just divide, right? So let's do that. All right. So for compound, let me just do this. Compound 1. It's going to be 42.9 grams of carbon over 57.1 grams of oxygen, and that's going to give you a number per 1 gram of oxygen. You know what? I'm not getting my calculator. I'll just use my phone. 42.9 divided by 57.1. All right, let's write this number down. It's going to be the same number we saw in a previous similar problem we did, 0.751. Okay, and then let's do this compound 2. Down here, so 27.2 grams of carbon over 72.8 grams of carbon, or oxygen, is going to give us again, it's going to be the same number we did in a previous problem, just using I think it was an 80 gram sample, not a 100 gram sample. 7, 4. All right, so I'm going to see how much the carbon in compound 1 goes into the carbon of compound 2. Okay, so here, final answer right here, 0.751 over 0.374, and it's going to be 2. Let's do it anyway. 0.751 divided by 0.374. Yep, that's 2. So that shows that the data supports the law of multiple proportions.